This is our pre-exam on momentum and our multiple choice questions, number 25. I'm going to do the problem long ways and then maybe show you a shortcut way to be able to do it on your test actually faster. But what we have is we have ball X initially at 10 meters per second, and it's going to hit Y, which is at rest. I do think it's confusing that they gave you balls X and Y when we need to break down this problem into X and Y components. I think that makes it a little confusing. But ball X is going to move off at 6 meters per second at an angle of 53. And we need to figure out which one of these answers down here is the correct one. Well, since it's an elastic collision, we are going to be able to say momentum is conserved. And we're going to use that to our advantage. So let's look at the long way of solving it. And I color-coded this to helpfully make it a little easier. If we have the initial ball of X at 10 meters, the Y was at rest, then X will move on at 6 meters per second, an angle of 53, and we don't know the angle or the velocity of Y. But we're going to look at just the X direction. And the reason I chose X is that there's no velocity in the Y direction beginning at all. It's all along the X axis, so let's use that to our advantage. And the momentum before has to equal the momentum after. That's due to it being an elastic collision. So if I wrote this all out, I've got the mass of ball X, its initial velocity, mass of ball Y at its initial velocity, and then the final velocities of both the respective balls. We know that the masses are equal to each other, so we're going to be able to cancel those out all the way through, which is really useful in the case that the masses are equal. And we also know that the initial ball Y was at 0, so all of a sudden, all it is that the velocity in the direction, in the X direction, initially has to equal the two velocities of these in the X direction at the end. And remember, we're talking just about the X direction. That's the only thing we're looking at right now. So initially it was 10 meters per second. That's what they told me. And if I take the 6 meters and if I take the amount that's just in the X direction, that's going to be the cosine, the adjacent, of 53. And I'm going to get that the velocity that I'm looking for in the X direction on Y needs to be 6.4. What that says is if I look at these two possible answers of D and C, if I look at D, the amount of the velocity that's in the X direction would be 8 times the cosine of this, which is 4.8. If I look at C, it is that 8, the amount that is in the X direction would be the cosine of the 37, and that's 6.4. So C has to be the right amount because that's how much is in the X direction. Now, if I was doing the test and I wanted to be a little bit faster, there's a few things I can do. I know it's elastic, my momentum is conserved. If the masses are equal to each other, and it says that they have the same masses, then I know mass is not a factor. So just get rid of it. Nobody cares. So I know that the velocity here in the X direction is 10. It has to be 10 total in this direction also. And the amount of 6 meters per second times the cosine of 53 is 3.6 meters per second. Then the amount of the other one has to be 6.4 meters per second because together they have to equal 10. Then all I do is I look at these two possible answers and I take 8 meters per second times the cosine of 37, and that gave me 6.4. And that's the quicker and faster way to do it. And the key was momentum is conserved, so I know my momentum has to be equal, and their masses are equal, so I just took everything in the X direction.